All right, so here we are in section 4.1. I'm going to go through numbers 9 through 26. So starting with number 9, so here we have t to the 4th times t to the 5th. So because both of these have the same bases, all we need to do is add the exponents to get our final answer. So we're just going to have t as our base here, and then 4 plus 5 is going to be 9. We know this because of the rule about multiplying by the same basis. Over here with number 10, it's going to be sort of the same thing, except now instead of adding the exponents, we're actually going to subtract the exponents. So we have p to the 8th divided by p to the 3rd. So p is going to be our base. And if we do 8 subtract 3, we have p to the 5th as our final answer there. Okay, coming over here, both of these are being multiplied together. So same basis, still x. But now when we add these exponents, that -2 is going to make this problem a subtraction problem. So we have 9 minus 2, which is going to be x to the 7th. Okay, then coming on over to number 12, we have y to the 5th to the 6th. So whenever we have a parenthesis like this, all we have to do with the exponents to get our final answer is multiply them together. So we have y as our base, and then 5 times 6 is going to be 30. Okay, number 13, again, we have to multiply that exponent in. However, this time we have two terms. We have r and we have 5. What we need to do with this 2 is distribute that in so that it goes to the 5 and the r. So when we distribute in air quotes with the exponent, really what we're doing is we're making this 5 to the 2nd, and then we're going to multiply that 3 and 2. So this r is going to be r to the 6th. So then to simplify this, all we need to do with the 5 squared is we need to make that 25 r to the 6th. And that's our final answer for number 13. Coming over to 14, each of these has 2 terms that we need to multiply by. So I'm going to start with the numbers here. So if we do that, we're going to do 2 multiplied by 9, which is going to give us 18. And then we're going to do a to the 4th times a to the 2nd, which we already know that if we want to do that, we have to add the exponents. So we're going to do a to the 6th for this one. Okay, and coming over to 15, again, we have a multiplication one. So what we have to do is we have the same base of g. But now that is a -8 times 7, which is going to make this a -56. Now, whenever we have a negative number as our exponent, what we need to do is make it positive. So how we do that is we actually have to make it into a fraction. So technically, this is g to the -56 over 1. So to make it positive, all we have to do is flip this around, and it becomes 1 over g to the 56. Okay, and then that would be the simplified final answer. Coming over to 16, this is another divide problem. However, when we do this, what we're going to do is it's going to be q -8, and then we're going to subtract a -12. So when we subtract a -12, we're actually going to multiply those two negatives together, and it creates a positive. So we're actually adding on that 12. So we have q -8 plus 12. So -8 plus 12 is going to equal q to the 4th. Okay, there's another way to do that one as well. If you want, you can make them positive by bringing that q12 up and that q8 down, and that will make them positive. And then when you have that, you have 12 minus 8. Either way would be correct. I just find that this is easier to just subtract them out and then see if it's positive or negative and move them from there. Coming over to 17, I'm going to use that same method that we just used, where we do minus a -2 for this one. because of that m to the negative second in the bottom. Negative times negative is going to equal positive. So then we have m to the 7th. Okay, coming over to number 18, we have, again, two terms on top and bottom. So I'm going to deal with the numbers first. I'm going to do 8 divided by 2, which is going to be 4. And then we have an x to the 7th divided by x to the 10th. So x to the 7th and then 7 minus 10 is going to be x to the negative 3rd. Now, like we did in number 15, if you have a negative on top, or a negative exponent anywhere in your problem, we need to change it so that it's positive. So technically all of this is over 1. What we're going to do is we just want to bring that x to the negative 3rd down so it becomes positive. So our final answer is going to be 4x to the 3rd. 4 divided by x to the 3rd. There we go. Okay, coming over here, it looks like we have the similar problem, but now 10 is on top and 7 is on the bottom. So what we're going to do is 8 divided by 2 is going to be 4. And then coming over to the exponents, we have x to the 10th, x to the 7th. So 10 minus 7 is just going to be x to the 3rd. Now this one is positive, so we don't have to change it. So our final answer is just going to be 4x to the 3rd. Coming over here to 20, again, so even though we've been dealing with numbers mostly, when we have an exponent on actual numbers that could simplify, we can simplify it and then multiply it out on a calculator if you feel so inclined. But how we would normally do it is, since these are both 3, we're going to treat it exactly the same. So it's just going to be 3 on the bottom. And then up here, we're going to add those exponents together. So we're going to have 5 plus 3, which is going to be 8. This would be an answer. If you wanted to simplify it further, you could put that into a calculator. And the answer for that one is 6,561. A lot easier to put it as 3 to the 8th for sure. Okay, coming over to number 21. So this one, we have a couple terms that we need to distribute that exponent to. So make sure that we distribute it to the 2 and to the c to the 8th. So we have 2 to the negative 3rd on top. And then on the bottom, we have c, and then 8 times negative 3 is going to be negative 24. So we have c to the negative 24th. Again, we need positive exponents for this to work. So I'm going to switch both of these up, and I'm going to make the c to the 24th be the numerator, and the 2 to the 3rd be the denominator. So when we switch those up, which is going to be 2 to the 3rd on bottom, and then c to the 24th on top. And now that we don't have a negative exponent, we can actually simplify this 2 to the 3rd a little bit more by making it c to the 24th still on top. But now 2 to the 3rd is going to come out with 8. All right, going on to number 22. Again, we are going to distribute that 2 to both of those terms in there. So m to the 4 times 2, which is going to be m to the 8th. And then on the bottom, we have n to the negative 3 times 2. So we have n to the negative 6. All right, so because we have that negative, we have to bring it up top to make it our final answer, to make it positive. So we're going to have m to the 8th, n to the 6th as our final answer there. Okay, coming over to 23, what we're going to be doing here is kind of what we've been doing so far. We're going to just take this exponent first, and we're going to distribute it to all of the terms inside, which this one has 5 terms that we need to distribute it to. Hold on, that was not good of me to cover up that problem. But we're going to distribute it to all the terms in here. So starting with the top, we're going to have 6 to the negative 4th, k to the 20th, j to the negative 12th. This is all because we're doing negative 5 times negative 4 for 20, and then 3 times negative 4 for negative 12. And then we're going to go to the bottom, and we're going to distribute there. So then we have k to the negative 20 and j to the negative 8. All right, so we have a lot of negatives, negative exponents in this problem that we need to take care of. So wherever it's negative, we're just going to switch it up and bring it either bottom or top. So this 6 to the negative 4th, we're going to bring it down to the denominator to make it positive. That k to the negative 20th, we're going to bring it up. The j to the negative 8th, we're going to bring up, and the j to the negative 12th, we're going to bring down. That k 20th up top is just going to stay the same. So when we write this out, I'm going to write it out k 20th, k to the 20th, because we brought that negative 20 up, and then j to the 8th. And then all on the bottom, we have 6 to the 4th and j to the 12th. Okay, so that should take care of all of our terms. So now we just need to simplify this. So we have k times k up here. So this should simplify to k40 because we're adding those 20s together. And then we have that j8 and j12 that we can simplify. So 8 minus 12 is going to give us a j to the negative 4th. But of course, now it's negative up top, so we need to bring it down. Another way that might be a little bit easier to think about this is when you have the greater exponent, like wherever the greater exponent is, that's where the number is going to end up. So you can just minus 12 and 8 and realize it's j to the 4th, but it's going to be on the bottom. So we should have k to the 40th on top, and then j4 on the bottom, and then that's 6 to the 4th. We can simplify that out. When we multiply it out, we're going to get 1296 or 1,296. And then that is our final answer for number 23. Coming over to 24, we have a negative exponent here. So what that means is that we have to bring that down to the bottom of this fraction so that now it becomes 1 over 5 to the second. It becomes positive. And then to simplify it further, we can just do 5 to the second, which is going to be 25. Coming over to 25. So here it's what we're going to do is we're going to look at the exponents. So we have same basis here. We have 38 minus 40. So you could do this where we just minus it out 40 and get 17 negative 2. And then since it's negative, we have to bring it down. So it's going to become 1 over 17 squared. Or we could have done it that the 40 is the bigger number. So if we just minus 40 and 38, we would have gotten 1 over 17 squared. So it's still the same thing, maybe just a little bit different way to think about it. So then when we do this one out on the calculator, we get 1 over 289. And that will be our final answer for number 25. Okay, last one here. So 26, same as 23, we're going to distribute that negative 2 to all of the numbers in here. So let's start with that 5. So on top we have 5 to the negative second. And then 3 times negative 2 is x to the negative 6. 8 times negative 2 is going to be y to the negative 16th. And then on the bottom, we have x to the 14 times negative 2 is negative 28. And then y negative 3, negative 2. So negative 3 times negative 2 is going to be y to the 6. Oh. So then going from here, we have a lot of negatives that we need to bring up and down. So I'm going to move this x to the negative 28 on top, the 5 to the second on the bottom, the x to the 6th on the bottom, and the y to the negative 16 on the bottom. We're going to keep that y to the 6th on the bottom because it doesn't have a negative, so we don't have to move it anywhere. So then coming over here, what our fraction should now look like is we have x to the 28 on top. We have 5 to the second on bottom. y to the 6th, y to the 16th, and x to the 6th on the bottom. So now we're just going to simplify all that we can. So there's two x's that we can do. So 28 minus 6 is going to give us x to the 22nd on the top. And then on the bottom, we have 6 plus 16 for the y's, which is going to give us y to the 22nd on the bottom. And then if we do out that 5 to the 2nd, we're going to get a 25. So then that's our final answer for that one. Okay, I hope this helped for numbers 9 through 26.